Okay, so how we measure these mass. We measured mass using a balance, an electronic balance. Some people got to use the triple beam balance, but we're dealing with balances. We're dealing with mass, and the units that we measure in are grams. And the definition would be the amount of stuff, or the amount of matter, or the amount of particles in an object. So how many particles are there? Volume we measured a couple different ways. Volume we used using a graduated cylinder. I'll just call it a grad sil right here. We also used a ruler and did length times width times height if it was a regularly shaped solid, a rectangular prism, if you will. So if I put something in the graduated cylinder, either I'm measuring a liquid's volume or maybe I'm using the displacement technique, I'm going to get units that are most likely going to be milliliters. If I do length times width times height, I'm probably going to get centimeters cubed. And volume is the amount of space the object takes up. So you kind of think of that like the size, how big it is. So just because something's big doesn't mean it necessarily has to have a lot of particles in it. All right, and then with density, we really just took mass and divided by volume on that. We could also do density from the slope of a best fit line. And then depending on what the density can have some different units depending on what the volume units are that we used. Since it's mass over volume, you could have grams over milliliters, or you could have grams over cubic centimeters. All right, and definition, it's the mass per volume. These definitions, notice I'm not giving the exact accurate scientific definitions, just showing that we could explain what they are. The amount of mass per unit volume, something like that. All right. On number 2, we have to demonstrate a couple things. One, we got to demonstrate that we understand that 1 cubic centimeter is equal to how many milliliters? 1 cubic centimeter is equal to how many milliliters? 1, right. So if this object has a volume of 42 cubic centimeters, that means its volume is also 42 milliliters, which means if we put it into water, it should make that water rise 42 milliliters. So it's going to displace 42 milliliters of water. Pretty easy. Number 3, write a for every statement. We've got this density. It's saying there's 3.70 grams per milliliter. So I would just say for every 1 milliliter, there are, remember this is, like I explained, this is important for your test. You're going to have to make for every statements. That's kind of the outline. For every blank, there are blank. For every 1 milliliter, there are 3.70 grams. I could say it the other way around. I could say for every 3.70 grams, there are 1 milliliters. All right, and then number 4. So if we know that there are 3.70 grams in 1 milliliter, how many grams are there in 10 of them? Just multiply by 10, right? If that doesn't make sense, just thinking about it logically, remember we do have this density pyramid, or sometimes you just see it as a circle, but it looks like this: mass on top, density and volume on the bottom. Okay. Well, what you do is whatever they're asking you to find, you cover that up. So if they're asking you to find the mass, and I cover up mass, then it's going to be density times volume. So I know the density is this, and this is why I said, guys, you got to get used to seeing these units and knowing it represents density if it's grams per milliliter, or seeing milliliters and knowing that that's volume. All right, so to find the mass, I need the density and volume. From question number 3, I know that the density is 3.70 grams per milliliter, and if I times that by 10.0 milliliters, I'm going to end up with 37.0 grams. No, not really. All right, and then we have number 5, so I'm going to have to erase this so I can scroll down. So what would the mass be of a 3.5 centimeter long, 7.0 centimeter wide, and 1.3 centimeter high block of the substance described in number 3? So it's still talking about that same substance in number 3. I know that the density is 3.70 grams. I should know by now, we should know that if they're giving me the length, the width, and the height, I'm probably going to have to multiply those together to find the volume, right? So if I multiply 3.5 centimeters times 7.0 centimeters times 1.3 centimeters, 31.85. Okay. And that is centimeters cubed. All right, so that's my volume. Again, so if I have this, that triangle thing, it's asking me to find the mass, so I'm going to do density times volume. So really the point of this problem is that you can use the length times width times height to find volume, but really you're doing the same type of deal as last one. You're going to take the volume times density, or density times volume. It doesn't matter which order they're in. So that times 3.70 grams per milliliter. Now we do have some different units for our volume here. One is in cubic centimeters and one is in milliliters. But since cubic centimeters and milliliters are the same value, it doesn't matter. I can just as easily say that this density is 3.70 grams per cubic centimeter as well. All right. So if I multiply those together, you should get a number around 118. And that would be the mass. All right. Number 6, show all work required to calculate the density of an object with a mass of 17.5 grams and a volume of 4.8 milliliters. All right, so again, we've got mass, density, volume. This time they want us to find the density. So cover up density. I've got mass over volume. So take the 17.5 grams and divide that by 4.8 milliliters. And you should get an answer like 3.65 grams per milliliter. Because that was the density given to us in number 3. So 4 and 5 both deal with the same object using number 3. No, because that part of the problem you're just so the questions are about this previous problem, number 5. So ultimately what we're trying to do on number 5 is we're trying to find the mass, okay? So in order to find the mass, we need to know the density and the volume. We already know the density from number 3, but we don't know the volume. All they give us for volume is they give us the dimensions of this, I can't say really cube, but rectangular prism, okay? So I got to multiply those together so that I can get volume, and then I can do density times volume equals mass. That makes sense? And that 3.7 I got from number 3, because we're still dealing with that object. Now at number 6, we're dealing with a new object. Maybe, I don't know, The density is pretty close to that 3.7 again, isn't it? If I rounded it off. All right, number 7, show all work required to calculate the volume of an object with a mass of 350.0 grams and a density of 16.7 grams per milliliter. So if I've got this, and I'm trying to find volume, cross out volume, mass over density. So if I take the mass of 350.0 grams and divide that by 16.7 grams per milliliter, that is going to equal 20.96 milliliters. That sound right? Something like that, something close to that. Number 8, which property of matter determines whether an object will sink or float in another substance? Density. If the density is less than the liquid you're putting it in, it will float. If it's more than the liquid you're putting it in, it will sink, or gas. Okay. Everybody good with those? Number 9, Katana pours 4 liquids into a glass beaker. Draw a picture of what the liquids would look like in the beaker. So here's my beaker, and we have 4 different things given to us, so we're going to assume they don't mix. We're going to assume that they make 4 separate layers. If they make 4 separate layers, I'll draw some lines here. There's 1 layer. There's 2 layers. There's 3 layers. There's 4 layers. And so out of baby oil, honey, rubbing alcohol, water, we got to see which one has the most density because that will go to the bottom. All right. So baby oil is just 0.82 and honey is 1.36. Rubbing alcohol is 0.87. Water should be 1. Does it say on here? All right. And so the highest of those numbers is honey. So that would be at the bottom. So maybe I just label it honey. Now I like to label these to the side because I also like to show off my knowledge of how the particles will look different in objects with different densities because that's a big part of our unit test, our success criteria that we worked on for like the last week. All right, so after 1.36, the next most dense is water. Okay. And after water, the next most dense is rubbing alcohol. And then after that will be the baby oil will be on top. And so if I do these particles, start at the bottom, make the dots close together. So that shows that we know the more dense it is, the closer the particles are together. And then the water, they're going to be a little more spread out. And then in the alcohol, they'll be even more spread out. And then in the baby oil, even more spread out. Okay. So that usually those types of models, like that particular one, usually ends up being worth quite a few points on your test. So make sure you know how to do that. And then number 10, write a for every statement for pine wood. So pine wood is right up here. And it has a density of 0.373. Got to pay attention to the units, grams per cubic centimeter. So it says for every, I'll say for every 1 cubic centimeter, there are 0.373 grams. I could say it the other way. I could say for every 0.373 grams, there are 1 cubic centimeters. Number 11, if a piece of wood has a mass of 5.41 grams and a volume of 8.5 cubic centimeters, what type of wood is it? Provide evidence to justify your answer. So when we're trying to identify substances, we talked about density being a characteristic property. Okay, so if we're trying to identify substances, I'll find the density. So if I cover up density, it means I got to do mass divided by volume, mass over volume. 5.41 grams divided by 8.5 cubic centimeters. And the answer comes out to be 0.636 grams per cubic centimeter. And if I look at the table, that's pretty close to 0.638, which means it would be ash. Reasoning. Evidence is my density, and the reasoning is density is closest to density of ash. Good with that? All right, and number 12, John has two identical sized pieces of oak wood, which has a density of 0.711 grams per cubic centimeter. He drills 3 holes in one of the pieces of wood and then places both pieces into a bucket of water. Describe what will happen to each piece of wood. Make sure you explain why using science concepts we learned in class. Well, they're both going to float. And so if we have a certain substance, in this case oak wood, it doesn't matter what the size or shape of the wood is, it's still going to have the same density. Okay, kind of like a question I was just helping out with up here where it asked for the density of the same substance, but it was 3 different volumes. It doesn't matter what the volume is. It doesn't matter what the size of it is. The particles inside are still going to have the same spacing. So density of both is less than water. And if the density is less than water, it floats. All right. Number 13, a rock dropped into a graduated cylinder raises the volume from 15 milliliters to 42 milliliters. This is displacement. This is displacement. So the water level was at 15 milliliters. I put this rock in, it goes up to 42 milliliters. So if I just find the difference between those two volumes, I'll find the volume of the rock. So the rock is going to be 27 milliliters. That's its volume. All right. It's telling us the mass right here. So if they want to know the density, cover up density, it's mass divided by volume. So 45 grams divided by 27 milliliters. And we are going to get an answer that is, according to my calculations, 1.7 grams per milliliter. Okay, compare and contrast physical changes. Well, matter is being changed in both of them. Both involve matter changing. If I contrast the two, though, with a physical change, no new substances are made. So what you're starting with, you still have at the end the same substance, like ice going through different phases. If we were to take an ice cube, it would have H2O particles in it. If we melt that, it's still going to be H2O particles. They're now just going to be in the liquid phase. If we boiled that, the water vapor would go into the air, but it would still be H2O particles. And if I went the other way, turning it into liquid or freezing it into ice, it's still H2O particles. We're not making a new substance. In chemical changes, however, we are. So in a chemical change, new substance is made. We have some evidence for that that I had mentioned, like energy release, bubbles, color change, formation of a precipitate, some of the ones I had mentioned. All right, what is the law of conservation of mass? This means that matter cannot be created nor destroyed. Okay, we can't just do these models and have particles show up from nowhere. And we can't do these models and have particles just disappear all of a sudden. They can leave a system, or they could enter a system, or maybe it's a closed system where they can't enter or exit. Okay, so we can see masses change during changes, but it's not because particles are disappearing, it's because particles are leaving the system. If we see that the mass has increased for some reason, it's because the particles must have entered the system. All right, almost done with this. So number 16, if each particle of hydrogen has a mass of 1.01 grams and each particle of oxygen has a mass of 16 grams, what is the mass of the product H2O? So that means H2O would be two hydrogen particles, each with a mass of 1.01. And then we would have an oxygen particle that has a mass of 16. So if I combine them together, I'm just going to add the masses together. Just put the particles together, stick them together, H2O. So it's going to be 18.02 grams, correct? All right, 17, similar concept. And this goes along with what you should have saw when we did the lab and we did the water, sugar dissolving in water. If you take 3 pounds of sugar and you dissolve it in 30 pounds of water, nothing's going to leave the system. Nothing's going to enter the system. What you started with is still going to be there at the end. So if I had 3 pounds of sugar at the beginning, I'm still going to have 3 pounds of sugar at the end. If I had 30 pounds of water at the beginning, still going to have 30 pounds of water at the end. The only change that's happening is dissolving something, which is breaking up the sugar into smaller parts. So 3 and 30 would make a total of 33 pounds of sugar water. Just add them up. All right, number 18. Imagine you have a 500-gram bar of chocolate. You chop it into a bunch of little pieces for chocolate chip cookies. After chopping the bar into small pieces, you put all the pieces on a balance. What would the mass of the chopped chocolate pieces be? So modeling-wise, let's say here's my chocolate bar. Should have spaced these out evenly, but oh well. That's terrible. Just an example here for modeling purposes. Okay, but let's say that's a chocolate bar with the particles inside. If I chop it up into pieces, and then put all those pieces on the balance, I'm still going to have the same mass. It's still going to be 500 grams. Is chopping the chocolate bar into pieces a physical or chemical change? It's just a physical change. Provide an explanation for your choices. Here I made a model, but really all we're doing here is changing the shape. That's all we're doing. So no particles are going to be lost. No particles are going to be gained. We're just changing the shape. We still have the same number of particles as in the beginning. We just changed the shape. And with number 19, when a log burns in a fire, the ashes have a much lower mass than the log. This seems to violate the law of conservation of mass. Explain why it doesn't. All right, well, the reason why it doesn't is all it's saying is if we have the mass go down, then the particles, some particles, I should say, left the system. Okay? And realistically, what you should know by now is that when you burn something, it's a combustion reaction. So actually, we're going to have some particles going into the system as well. We'll actually have, if this is the system here, we would have oxygen going in to the system for burning it. But then we're also going to have smoke leaving. That has particles, water vapor, CO2. Okay, those things are going to be leaving. So that's 1 through 19 on your review.